Oh, okay, good afternoon. So I will continue teaching you a little bit, but as I told you, this part will not be included in the exam next Tuesday. It will be the topic of the next exam. Okay, so what we do here is we want to talk a little bit about equations. So the topic is still algebra, but so far in algebra, we learned how to simplify expressions, algebraic expressions. But here we are not focusing on finding simplifying algebraic expressions. We want to solve equations. So first of all, you need to understand what is the meaning of an equation. Yes. So for example, an equation is an expression including equality sign, but it is not the case that it is always true. Yes. For example, I want you to appreciate the difference between identities and equations. For example, when I write 2 times x plus 1 equals to 2x plus 2, it includes this expression that you see, includes equality sign, includes one variable. But this is valid for all possible choices of x. Yes? Okay? So this means that why this is always true, because independent of the value that you choose for x, if you expand this, it becomes 2 times x plus 2 times 1, which is 2, and this becomes exactly the right hand side. So the left hand side, regardless of the value that you choose for x, is always equal to the right hand side for that particular value. So this is called an identity. Okay? And if I want to say something about identities, I can ask you show the truth of this identity. Identity means an equality which is valid for all possible choices of the variable. Yes? So it doesn't matter what value I choose for x. If I calculate the left hand side for that value, and if I calculate the right hand side for the same value, the answers are the same regardless of the value that I choose for x. If this is the case, I am facing an identity. This is the terminology I want you to learn. But and if I want to say something about identities in the exam questions, I cannot ask you, for example, solve the following identity. I can ask you show or prove the following identity. It means that you need to tell me why this equality is valid for all choices of x. That is called proof or showing that. But on the other hand, equations are also very similar things to identities. For example, instead of having this situation, I can just take this away and write 2. This is no longer an identity. Why is that? For example, if you expand the left-hand side becomes 2x plus 2, but 2x plus 2 is not always equal to 2. Yes? So this is very similar in structure to this, but the difference is that this one is not always true. Okay? But this is always true. So this is called an equation. I want to solve an equation, yes? Here I want to show an identity. So that's the difference. And I need you to know what is the meaning of solve an equation. So when I say an equation, it means that you expect to see a equality sign with some unknown variable there, but you know that this is not the case, that this is always true. By solve, I mean go and find all possible values for x so that this equality becomes a true equality. Yes, that's the meaning of solve, and I emphasize on the word solve. On the word all, that is important. For example, here, for example, x equals to 0 is a solution to this equation. Do you agree? Because if I replace x with this given value, the left-hand side becomes 2 times 0 plus 1, which if you calculate becomes 2 times 1, which is 2. So for this value of x, the left hand side becomes equal to the right hand side. So the terminology that we use, we say that this is a solution, or sometimes we say it is a root of this equation. So the answers to an equation are sometimes called solutions or sometimes called roots. Yes, so that word I want you to know as a terminology here as well. But I cannot claim that I solved the equation. Might be I was smart enough or lucky enough to be able to guess an answer. But this by no means that I solved the problem, unless I can convince myself there are no other solutions. So that's the point. Even if you luckily or smartly come up with an answer for an equation, and even if that answer that you found is correct, but you cannot say that, okay, I solved the equation, because this is always the possibility that there are other solutions that you were not lucky enough to guess. Okay? Or they were hard, they were not clear so that you can guess. Okay? So for example, I can give you this equation to x to the power of 2 plus 2x equals to 3. Okay, so this is also an equation. Why? Because first of all, you see equality sign there, and then you have an unknown which you are supposed to find, and this is not the case that this is always true. For example, if I choose x equals to 0, for example, the left hand side becomes 0, the right hand side is 3, so it is clear that for some values this is not true. Okay, so that's an equation. Okay, this I intentionally wrote it in a way that you can guess. Okay, so can you guess a solution for this one? Can you guess a value for x so that when I replace x with that value, the left hand side becomes equal to 3? It's not hard to guess. 1. So if I write x equals to 1, and you say that, okay, I solved this problem, I will not accept it from you because there is no guarantee that there are no other solutions to the same equation. So what do you think about this? Are there other solutions for this equation?
Yeah.
What is that?
Well, I don't know, but
Yeah, you can use that. But I mean, for example, so that's what I'm trying to tell you, that if you have an equation, and even if you can guess an answer for that equation, you cannot claim that I solved the equation, because the word solve means find all of them. Okay? So that's important. Okay, so for example, in this case, another solution is probably minus 3, which probably we will not able to guess immediately. It is not hard, by the way, to guess, but minus 3. So because if I check minus 3 here, the left hand side is minus 3 to power 2, which is 9. 2 times minus 3 is minus 6. And if I add these two numbers, it becomes exactly 3 again. So this means that x equals to minus 3 is also another root. And again, there is also this risk that are there other solutions as well that we cannot guess. That's what I don't want, because we will talk about these kinds of equations in Math 2C and onwards. But just I want you to understand, even if you can guess an answer, that is not enough. Okay? Unless you show me these are the only ones. And this argument is not that easy. For example, here, I was able to guess 1. I was able to guess minus 3. The problem is not finished yet unless I can convince you that no, there are no other roots except 1 and minus 3. So this means that I have to have a valid argument, solid argument to convince you of that. Okay, so let me just summarize that. If I give you an equation, by the way, the bad news is that most of the equations we cannot solve. Okay? So many equations that appear in science and engineering are those type of equations that we do not have any formula how to solve them. You don't need to think about a very, very hard equation. No, even for example, if I just write x to the power of 3 minus a square root of 2x plus, I don't know, 7x squared minus 1 equals to 0. So very probably we cannot solve this equation. Okay, so it's not, you don't need to think it's a very, very complicated in form. No, it's probably very simple. Even if I put 2 here, might be still we cannot solve that. Okay, there are methods that we can solve for third degree equations. This is a third degree equation because the highest power is 3. For the second degree equation, we learn it in high school. For third degree equations, you do not learn it in general. For 4 degree equations, we can do something, but no, Abel, Norwegian mathematician, actually showed that if the degree is 5 and higher, it is not possible at all to find a formula for solving them in general. The highest power is 5 onwards, yes? It doesn't mean that we cannot solve any 5th degree equations. Yes, we can. For example, if I say that x to the power of 5 minus 1 is equal to 0, this is an equation of 5th degree because the highest degree, the highest power of the unknown is 5. But you can easily solve that. What can you give me a number so that when I raise it to power 5 minus 1 becomes 0? 1. So you see, you can solve that problem. It doesn't mean that, but if I start adding other terms, for example, if I write x to the power of 5, 7x to the power of 4 minus 3x to the power of 3 plus 2x to the power of 2, I don't know, minus 1 equals to 0, then it is more or less impossible. So that's what I want to understand. So I want you to understand the topic of equations could be extremely hard. Not hard for everyone, because there is no way we can solve those. But the good news is that usually in science and engineering we do not need exact values. For example, mathematicians usually work with the square root of 2, meaning that hypothetical number so that when it squares it becomes 2. But for an engineer, a square root of 2 is probably 1.41 approximately. Or if you need more precision, you can go more decimal, you can go forward in more decimal places. So when it comes to practical purposes, engineering and science, yeah, still we can solve them. But the methods that are applied to solve these kinds of equations are actually above the high school studies, okay? But the bad news is that. So the bad news is that in principle, solving an equation in exact form is impossible. But the good news is that mathematicians have developed some kind of techniques, of numerical analysis techniques, so that you can find the roots of more or less every equation that are important from practical point of view to any degree of accuracy that is needed. That's the good news. Okay. Today I want to talk a little bit about these preliminary stuff, but of course mainly thing that we learn in Math 1C is solving first degree equations that more or less you learned in grade school on. Okay, we just make it a little bit more advanced than there. Okay, but so I told you that solving an equation is usually hard, but if I give you the answer and ask you, is this an answer for this equation, this is usually not hard. So what you need to do, you just replace the x in the equation with the proposed value and then check if the equality is true or false. So for example, I didn't solve that problem. I will not ask you to solve this type of equations in Math 1C. I will ask them in Math 2C. But still in the next exam, I can ask you, is minus 3 a root of this equation or not? So this is something that you can immediately check. How do you check? You just replace the x value with that proposed number to see if the equality turns out to be a true equality. If it is, you say that yes, this is an answer. If not, you say that this is not an answer. Okay? Yes, but that's exactly what I'm saying. What I'm saying is that if the answer is already proposed, investigating if that answer is a true answer or false is not hard, even if the form of the equation is really complicated. Yes? But on the other hand, if I just give you the complicated equation without proposing any roots, and I ask you to solve, even I myself cannot be able to solve it. Yes, that's what I'm saying. This is the nature of equations. So don't underestimate this. Solving equations on the one hand are really, really necessary because, for example, in science and engineering, we are looking for an unknown. We have a model. We know the laws of nature, how it governs the situation. We've come up with an equation and we want an answer. So we have to solve an equation and find an answer to our problem. Yes? So in that case, equations are indeed very, very necessary. And unfortunately, this is not always possible to solve them in closed form. With a very nice formula and structure. Yes? Is that clear? Okay, I really like the way that Origo actually starts talking about equations. So this idea I want to teach you, just this page. Okay, for example, let me ask you, let me just start the example given in the book itself. So they are asking you to solve this equation. 1200 divided by 5 times 2x minus 6 is supposed to be equal to 12. And I think the idea that they are trying to explain with this picture is actually exactly the same idea that I wanted to talk about. So if I ask you to solve this equation, let us review this. First of all, is this an equation? Yes, because how do you see that this is an equation? You see an equality sign in your expression, and you have one variable here. Of course, you know that sometimes the variables are more than one, but we are not dealing with those equations. We are only dealing with equations with one unknown, okay? For the time being, of course. So then, this is not valid always. For example, if I choose x to be 0, then this becomes minus 6 times 5 is minus 30. 1200 divided by minus 30 is minus 40. And it is not equal to 12. So you realize that this is not an identity because, for example, it was not valid when I choose x equals to 0. So this is an equation. I cannot ask you to prove this because this is not an identity. I cannot ask you to show this because this is not an identity. Rather than that, I can ask you to solve the following equation. Yes? This is the terminology that I use. If I want to ask a question regarding this, I should start with solve the equation. What do I mean by the word solve? I mean find all x's that if x here is replaced with those values, this equality is a true equality. That is the meaning of word solve. Okay, so that idea that you just mentioned, actually this is the true one. So you see here, you don't know. So here on the left hand side you have a fraction. This fraction is not known to you yet, because a fraction is known to me whenever its numerator and the denominator are known to me. Yes, the numerator is exactly known to me. I know the exact value. It is 1200. But the denominator is not known to me. So this is some kind of a black box for me. Okay, so what I say is that 1200 divided by a box which I don't know what is inside that box, but I know what will be the answer. So guessing this question mark at this level is extremely simple. So you want to put some number in this question mark so that the calculation gives you 12. What is that one? 100. So you see, immediately you realize that this box is what? 100. Okay? But what is box? 5 times 2x minus 6 is your box. Is 100. And again now, this product is not known to you. The first factor is exactly known, but the second factor you don't know. So now this plays the role of your black box. Yes? 5 times something is 100. So what is that something? So to this box is what? 20. Yes? And then again, you would say that now this this subtraction is not known to me because the first one is not known to me. So this played the role of that box now. So box minus 6 is supposed to be 20. So what is inside the box? 26. So this means that 2x is 26. And again, this product is not known to you because this one you don't know. But you know 2 times of that is 26. So eventually you find what? X is equal to 13. So this idea is actually a very nice idea, so that you can try to understand. You don't need to write this down, okay? I want you to just understand what is going on. So we started from this equation. This type of equations probably you haven't seen before, but that is the goal. The goal is that I wanted to teach you in a way that you really don't need a teacher. Yes, because it was easy. You ask yourself, 1200 is divided by something which I don't know, but the answer I know is 12. So that something should be 100. And then when 5 times of something is 100, that thing itself is 20. And something minus 6 is 20, so that something is 26. 2 times something is 26, so that something is 30. So you finally just try to solve the problem in that way. Yes? Sometimes it is possible, sometimes it is not. For example, here, this is not possible. Why? Here. That method is not probably working here because I have the unknown appearing in 2 positions. So here, let us look. You have an operation, division. Division needs 2 numbers. One of them is known, the other one is unknown. So one of them is not known. And then when you come here, it's a multiplication. One of them is known, the other one is not known. And here you have subtraction. One of them is known, the other one is not known. And here you have a product, one of them is known and the other one is not known. So whenever you have this situation, you can solve always using this trick. But here we cannot. Because here I have an addition, but both sides are not known. Okay? So this is this hard situation. That is not a hard situation.
I'm sorry, wait. What do you mean that both sides do not know which side there is not known?
So here when I have addition, I have 2 numbers added. If I ask you, do you know this number? You would say no, because this is x squared, still I don't know x. Do I know this number? No, because still I don't know x. But if you analyze this problem, at each stage, I am facing an operation, but one of the elements in that operation is known to me. I just try to look for the other one. Is that clear? So this method is useful if you are facing these kinds of equations. So let me give you another example. Let me choose it from the book. Now let me choose it myself, okay? They are more or less repeating the same thing over and over again. So, for example, let me ask you this question. So I will give you square root of, and then we will have, for example, 30 divided by, so let me make the numbers so nicer. Okay, so now here, let us try to solve this problem. So what can we do? Here, a square root is applying on some number you don't know. Why I don't know it? Because I don't know x. If I don't know x, the denominator is not known to me, so this means that the whole fraction is not known to me. But I know a square of this box, which I don't know what it is yet. is 5. Yes? Yes. So it means that I am asking myself, do I know something about this? Yes, because the square root of that black box is supposed to be 5. There is only one choice for this box. What is that? 25. So from here, this means that you get this 25. Yes? And then again, this fraction is not known to you because its denominator is not known to you. But you know something. But of course here I made it a little bit harder. You can simplify things first, yes? Because this 6 and divided by 6 is 1 times, and this by 6 is 5 times. A little bit guessing is a little bit harder. Can you guess it now? So 5 over 3 minus 2x is 25. So this is the box that you don't know. But you know something. You know if you divide 5 by that number, it turns out to be 25. So can you tell me what is the box? Yes?
That 3 minus 2x turns into 5.
No, because if 3 minus 2x is 5, then 5 divided by 5 becomes 1. So it 0. So I mean 1 over 5. Yes? So this box should be 1 over 5. So this means 3 minus 2x is 1 over 5. Yes? Because this is 1 over 5. But now I ask you, what is x? You would say that I don't know this, but I know 3 minus that number is supposed to be 1 over 5. What that number is? Because in 3 you can write it in your head as 15 over 5, yes? 15 over 5 minus something is supposed to be 1 over 5. So what is that something? 14 over 5, yes? But 2 times this unknown is 14 over 5. What is that unknown itself? 7 over 5. So you were able to solve this equation, yes? So this is the method that they are using it in this part. I told you that this will not be included in the next week exam, but it will be the content of the other exam. Okay, I will not continue more today because I want to give you time to practice, and if you have any questions, let me know. But I will update the Google Classroom which pages I have read. So what I write on a Google Classroom from now on will be the topic of the coming exam, not the exam on Tuesday. Okay? Any questions? Okay, thank you.